Okay, let's start. I know it says 7 minutes, but let's just start. Okay. Let's start by creating a gem file. What do we have here? No framework today. Yeah, some print. Let's throw RSpec there just in case. I don't think I will be doing any testing. And let's create, oh well, let's go to learn here. Ruby object mapper is a fast Ruby persistent library with the goal of providing powerful object mapping capabilities. Okay, I've read this in the past. Let's just skip it. Why use it? Principles and design. Inspirations. Next. Okay. Rails comparison. I don't want to use Rails. Let's jump right into the core concepts. Sorry for the noise. Before you start writing any data code, access code, it's a good idea to get a high-level overview of what each major component is and overall purpose. It's a series of abstractions built on one another to create a very flexible system. The following diagram shows the overview. Okay, so this is the application domain. So yes, we have repositories as the entry point to the system, and the repositories exchange entities in and out. That's very nice. So request an entry, configures relations for request. The relation is the one that makes the DB specific query. It asks to the database, it returns raw data, the relation maps to the entity, and it returns an entity. And for an update, we send an entity, map entity back into format understood by data store. Okay, so we generate data that will be understood by the database. Relations and datasets and the commands. Okay, and update the data. Data flow, reading data, application domain has the need. Okay, this is what I read. Reading data, step 7. Repositories provide a powerful CRUD interface built on top of relation, mapping, and command APIs. They give you a simple way for composing data provided by relations, automatically mapping data to structs or custom objects, and expose simple access to commands with support with forced changes. An important function of a repository is to act as a boundary between the data access logic and the application domain logic. This boundary helps to reduce the complexity of rehydrating your entities. Okay. Relations is defined as a set of tuples identify the unique pairs of attributes and their values. In ROM, it is an object that responds to each, which yields hashes. It is backed by a dataset object provided by the adapter. Okay, just below. Yeah. An example of relations are tables in SQL Server. In a SQL Server, tables can reference another tables. Commands in ROM are intended to safely modify data. Commands can be used to create, update, and delete. They are usually provided by the adapter, but okay, we went to the core concepts. Let's go to the setup DSL, and here the magic starts. So I think we'll be using, let's put the most important gems on top. ROM, and let's go with ROM SQL. So connect to a single database. Okay. Let's run bundle. 5, ROM SQL 3, we have dry struct 1, where do we have it? Try types, okay. So we are trying to create something like an app. We are trying to create some not just a file, but all the configurations and all that, simulating we are writing an app. But we will start with just this. Okay, first of all, we require awesome print, so we have nice colors, and let's Sqlite 3. We will install Sqlite 3. Do we have a Postgres SQL application? Ah, no. Let's just start playing with this. So, connect to a single database, call ROM container with the adapter symbol and configuration details for the adapter. Okay. We'll run bundle exec ruby app.rb and yeah. So it says an initialize constant ROM. Okay. Oops. Require ROM. Recompile. Nice. Okay, so that's ROM configuration. Yeah, I'm not interested in reading all of that at the moment. Let's continue reading. Connect to multiple database. Huh. Let's do this. Let's make this bigger, this smaller, and we have color, yeah. Okay. Sometimes you have multiple data sources. You can provide multiple gateway configurations. Okay. Okay. I don't want that now. This set of call is equivalent to default. Okay. Access the container. ROM container always returns the finalized environment container object. This object is not global and it must be managed either by you or the framework that you use. Okay, let's define our container. Okay, let's start by learning how to read data. Reading simple objects is the best to create multiple repository classes that each focus on one segment of the data. One rough guideline is to make a repository for each concept in your app. I don't remember if this goes to creating something like an example for the whole thing. So what we are gonna do is assume it does, and if it doesn't, we'll just change it later or do something else. But for now, let's just follow this. I'll try not to copy. I know I already copied some text, but I will try to not copy. To fix it on my head. So we say config.relation users do schema. I think this infer true. What it does is actually infer the data structure on the table we are using, or something like that. Auto struct true. This will try to convert it to a struct, to a dry RB struct, I think. By default, instead of returning just bare hashes, config relation so we have users and projects, schema infer true, and okay again. Okay, I'm not really sure what I'm doing here. Perhaps one repo to handle users and another to handle projects. Okay. User repo, it's a ROM repository of users, and I think this this symbol has to be one of these, either this one or this one. Oops. Or this one. I don't remember that, but let's keep reading. And project repo is a ROM repository of projects, and then we just instantiate it. User repo equal user repo dot new, and we pass the container. and it's a project repo, and we pass the container. Okay. While defining a repository, we'll also define its interface for domain-specific queries. These are called selector methods. They use the querying methods provided by relations to accomplish their task. For example, the ROM SQL adapter provides methods like where. We are using Sqlite memory, okay. Okay, so we can say on the user repo, we can say query conditions users where conditions and IDs users plug ID. So we have a user's method here that I think it's provided by this being a repository of users, and I think it's a relation. So for example, let's say user repo .ids config where blew up because table users probably doesn't exist. Okay, we need to create the table and all that. So on the config config.default connection create table users do primary key is the ID, create a column called the name which is a string and it's not nullable, and an email. And now I think I can run this. Table project, okay. Let's just copy this for now. For projects. Just a name. Okay. Undefined method now for project repo class. Line 48. Oh, new instead of now. Okay, yes, so this users is a relation, and it's this relation that we are creating here. Okay, yep, sounds good. Okay. Oops. What else? What else? What else? User repo. Users by ID. Okay, let's try to fetch some information. Although we don't have anything on the database. By ID users by primary key ID dot 1, and I forgot it to A here because I think this will return a relation. Not really sure. Okay. Notice that users where and users by PK are SQL specific interfaces that should not leak into our application domain layer. Okay, yeah, that goes inside there. And then in our application we can use the selector method user repo by ID 1 and this, oops. The relation 1 doesn't contain any tuples because we don't have anything on our database. Read complex aggregate data. Now, what we will do is reserve this for now. Core concepts, setup DSL, Rails setup. Okay, no, let's, instead of doing it for later, let's do it now. Have a powerful APR for composing data into nested structures, which we call aggregates, where the root is constructed from the data provided by the root relation, and additional relations provide data for child nodes. This document uses ROM SQL, which provides support for defining canonical database associations in relation schemas, which are used to simplify reading aggregates. Relation schema. First, we want to define our canonical associations. We call them canonical since they are defined by our database schema. It's common to diverge from canonical associations and compose data in different ways, depending on our application needs. However, in the early days of every project, using canonical associations is all you need. We are going to define users that have many tasks. So we have users with name and email to keep simple. Okay, so instead of projects, we are using tasks. So the user has 2 columns, okay. Now this till tasks, primary key ID, foreign key user ID refers to users, and instead of name this is called title. Relation users, conf relation users do schema infer true, and inside the schema, okay, we remove that because it's not using it. Do, and we have associations. Do has many tasks, and the relation tasks schema infer true, associations do, and belongs to user. This is very similar to Rails, at least on the naming. With associations defined the relation schemas being established, common queries that will be automatically used for composing relations into aggregates. Let's see how we can leverage that in repositories. Repository aggregate on the user repo. So this one is gone. And let's return user with tasks. Okay, let's say we'd like to expose an aggregate where a user is loaded with these tasks. We need to define a root repository with users set up as the root and provide access to tasks relation. Okay, I will need some data here. Combine wrap. Let's duplicate and very quickly try to write some information. Okay, so working with commands, update. I think this is done by the repositories. Repository create with tasks. Okay, let's just put this here without reading anything and create with tasks. And just paste it there. So we are creating a user named Jane with two tasks, task 1 and task 2. This blew up, and that's because I will remove this. So we have Jane, and let's Mary. Oops. Mary example.com. Mary's task 1. Now let's be more imaginative here. Buy pizza. Eat pizza. Yes. Okay. So that should be saved. Now let's go back here and yes. So user repo by ID 1 tuple count mismatch. Okay. User with tasks. And this returned user combined. Okay, let's start by calling a query, and for example say ID 1 name Jane. Oh, okay, I see my problem. I am working on memory here. So what we need to do, okay, since this is memory, well, first, why am I throwing anything here? Yes, we have a user. ROM struct and user repo, and it's called user with tasks. 2A, and it returns Jane. Nice. Let's create Mary again. Mary and again buy pizza and eat pizza, which is very basic. Nice. There. Let's try to remember how to output colors always. Color plain false. HTML false, plain false, supported colors. Why isn't it outputting color? Why? I want my colors. I want my colors. Come on. Come on. Sort. 319 class name, object ID, indent, index. I don't know. I don't know. I assume if I say through here, no colors, no colors, but this supports colors. Why isn't it using colors? I wonder. cd code ROM app Ruby app. Okay. I don't like this. Okay, no worries. I won't deal with that now. So we said that user with tasks is that, and if I say 2a, it returns the users and the tasks, which is nice. And if I say 1, consists of more than one tuple. Okay, that's this will work. Oh no. Oh, because I messed it up. Dot 1 and nothing here. So okay, nice. Okay, so far so good. We can do the other way around, starting with tasks relation as the root. Okay, which means we need to start creating the tasks repo, which is which is a ROM repository of tasks and tasks with assignee is tasks combine user. And we can say task repo dot tasks with assignee to A, and we have all 4 tasks: task 1, 2, pizza, and pizza. Oh, I forgot here. Yes. Okay. Relation combine, relation wrap. It's okay. I want to keep reading about repositories. Where are repositories? Call relations, schemas, associations, combines. Okay, now let's go to the writing aggregates, although I already did it. We have users with tasks, and we'd like to persist nested data, which represents this association. Once we establish canonical associations for our relation, okay, what do we have here? I think it's the same. Yeah, we have a foreign key on the task. We have users have many tasks, and tasks belongs to user. Once we establish canonical associations for relations repositories will know how to prepare commands for persisting nested data. Let's define a repository which exposes an interface for persisting a new user along with associated tasks. Okay, let's remove this. And create it by hand. Create with tasks. And we pass in a user and say users dot combine tasks command create. User, okay, and I assume, yeah, I'm assuming let's make it blow up. Dot create tasks, and we will pass in a user with name Peter, and this should blow up because we have, yeah, because of a null, not null constant on email. Email, say Peter at example.com. Let's run this again. Don't have any task. Key not found. Tasks. Okay. tasks, and it should be an array, and the task have a name, a title. Okay, title. Start OBS. Open Twitch dashboard and start streaming. Let's see what does this return. Okay, returns the user. And now we can say user repo dot by ID. I assume this is 3. Relation does not contain any tuples. Okay, 1 should be Jane. Oh, okay, yeah, I removed. Let's see. Okay, we have Jane, Mary, and Peter. Okay. And now again, we should be able to say user repo by ID, I think, 3, and this should be Peter. Need to print it, Peter, and if I say 2, this is Mary. Yes, very nice. Okay. So now we know how to save, and we are saving aggregates, so I can say user repo dot user with okay, first let's do something here. we want user with tasks, and let's say we pass a query. I think that should work if I say where query dot combine tasks. So user repo dot user with tasks, and we want name is Jane. To A. Or we can say here ID 3, and it should return Peter and all his tasks. Oh, this is nice. This is nice. But I think yeah, I think the idea here is to maybe put this as a private method, and this is this should still work. Although we don't need this. Yeah, and this 2a it doesn't belong here. Now I wonder what will happen if I say .each here, because this returns. Oh, okay, no. What I wanted to do is this. This returns a relation combined. .each, I assume we have a user here. ROM struct use. Oh, nice. So now we can say user.name. And we can also say user.tasks.each do puts. Has two. And here we should have a task. So, two spaces dash task.title. Oh, okay. I think I know why that happened. No, I don't know why that happened. ROM struct. Task.inspect is a struct. Title by pizza. Oh, I'm an idiot. Puts here. And now Mary has to buy pizza, eat pizza. And Peter has to start OBS, open Twitch dashboard, and start streaming. Okay, that's nice. Nice, 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 nice. Set up DSL. And let's try the explicit setup. So for the explicit setup, block style setup is suitable for simple, quick and dirty scripts that need access to databases. In typical application setup, you want to break down individual components definitions like relations or commands into separate files and define them as explicit classes. ROM frameworks, okay. Setup. To do setup in flat style, create ROM configuration object. This is the same object that gets yielded into your block in block style setup. So the API is identical. Okay. ROM configuration new. Oh, okay. So I think, oops. I think if I comment this and that, I can say configuration equal ROM configuration dot new that, oh okay, is equal so we have our configuration object and we define our tables. So these are create tables, and now we have relations, and now we have repositories. And okay. Okay, and after each relation we need to register relation I don't know, user relation. That should blow up right there. Uninitialized constant user relation. Okay, because it doesn't exist, it doesn't create it by default, but we'll skip this for now. Auto registration. ROM provides auto registration as a convenience method for automatically requiring and registering components that are not declared with the DSL. At a minimum, auto registration requires a base directory by default it will load relations from base relations. Okay, what is base here? Lib. Okay, namespaces inferred from directory structure. By default, auto registration assumes that the directory structure reflects your module class organization. For example, lib relation users. Okay, so what I'm understanding from this is that I have to create require relations slash users or is it lib relations users? Not sure. Okay, I will comment everything below this. I will create a lib relations users file, and this should be a class. Okay, I believe okay, I need also the tasks relation lib relation tasks repositories. Okay, let's start by uncommenting this and only this. And this and this. Okay, I will I will uncomment all this. And now if I run it, it says undefined method schema. Oh, okay. Because this needs to be relation users needs to be a ROM relation SQL, I think. It says memory here, but because, yeah. And tasks, same thing. And now it blows up because there is no method ROM. So ROM should be ROM container configuration. I think that's what we need. Wrong number of argument. Okay. ROM configuration, ROM container configuration. Oh, okay. It's from dot container, and we pass the configuration in. Users doesn't exist in ROM relation registry. ROM element not found error. Okay. I'm missing configuration dot auto registration path to leave uninitialized constant leave. FedEx code ROM app initialized constant leave. Why? It's not that. Require cannot load such file. Leave relations tasks. Leave relations it's not a syntax error. Cannot load such file. Sorry. Okay, it's trying to load it. But if I save this, exec ruby app cannot load. Oh, okay. Gem file. Oh, it blows right there. Okay. Step. And define method Oh, metaprogramming, that's nice. How am I supposed to do this? What? Okay, up level is 1. Ensure up level fits along 1. Okay. Up level greater than 0. Start equals 0. Color locations. Color locations. Core X warn. What? No more backtrace. Log path. Same thing. Okay, we need to reread this because I'm missing something here. Namespaces inferred from directory structure. By default, auto-registration assumes that the directory structure reflects your module class organization. For example, module relation class users. This is what we have. We have inferred true. Schema inferred true. Okay, but that infer is something else. Then to set up auto registration, simply provide the root path to your components directory. And that's what we did. What's the problem here? What's the problem here? Auto registration. /lib, no such file or directory app.rb. What? An initialized constant lib. Okay, why? And I said that's not it. So it is taking this last segment and trying to use it as the as a module. I don't know why. Does it work differently? No, same thing. Oh. Huh. Okay. So I imagine if I go to lib relations tasks and I create a lib, this should work. Why? Okay. What if I think at some point this was working. Persistent. Okay, and leave relations tasks. And now it blows up because schema parsing return node no columns. Say what? Now that said, I don't really like that. I also don't like that I have to add the persistent prefix to any column. So leave command, leave mappers. Namespace false. Let's try that. Uninitialize constant tasks. Name error. Okay. Where am I using? User repo. Okay. We should create now leave repositories user repo.rb and task. We don't need to require anything. Run again. Initialize constant tasks. Why? Class tasks. Oh. Uninitialized constant user repo. Did you mean users? No, I didn't mean users. Okay. So now this is working. Now this is working. I like it. But I'm not happy with everything I did today. I still need to understand this because it's not pretty. We have the container. So repositories are not auto-registered. Same for the commands. Repository. Relations can declare a specific gateway and dataset. The first argument to schema is the dataset name. By default, it's inferred from the class name. Under this name, the relation will be available in repositories. Oh, I can. Okay, I like this. I like this. Okay. I think I'll stop here for today. I have a working pseudo application with SQL persistence on memory. So yeah, I think the next thing I will try to learn is how to set up migrations. And to use a SQL database like Postgres instead of memory, or Sqlite. So I'll try to make a small application or pseudo application with the PostgreSQL database with migrations, and I assume I will be able to create, destroy, rebuild and all that, the database, and maybe even seed it. So let's stop here for now. Okay, thank you for watching. Bye.